Hello there, folks. Can everybody see and hear me? All right. Thank you all for coming out today. I appreciate it. Today we are going to continue on with Fly to Learn. We are going to specifically discuss thrust. We will be talking about landing our plane appropriately and not just all willy-nilly. And we are going to talk about flight controls and stability. So, pretty exciting day today. Next week we will be working with PlaneMaker as well as X-Plane. PlaneMaker is basically a way that we can edit the current aircraft in the software, and we can even make our own if we really wanted to. So I did hear that Mr. D did not hand out the full version of X-Plane. A little irritated about that, since he said he was going to, but I guess for now I really hope that we could just deal with the demos, since I think we're all done with lab except for maybe one or two sections of it. I know Raleigh, Harrisburg, and one of Charlotte's are done. So when you get on X-Plane, doesn't it show the little white plus sign? Does it show the square at all? Are you able to control your plane at all? Because that's an issue if you can't control your plane. Really? You've tried multiple planes, right? So basically, the software is not working at all for you. Huh. Alright. Let me get your email real quick. Today what we're going to be doing is stuff that I can also show you, but I'm going to do some snooping around on the interwebs and see if I can find any solutions to that problem, because that's a kind of a big problem. So for today, I'm just gonna have you watch, but I want to get this for you by next Monday. So that said, next week is our last week of webinars. We'll have webinar Monday and Wednesday, and that's it for the semester. I'm not sure when spring semester webinars start. I know it's mid-January, but I'll get back to you on the specific date of that. Ooh, excuse me, I have hiccups. But for now, are there any questions on what I discussed last class? Anything about drag? I'll be doing a few questions, these questions specifically, in a minute after I do a quick recap on what we learned last class. Alright, no questions? Alright, cool. Last class we did go over lift and talked about how important, lift is for planes to fly. We did discuss the two different theories of what causes lift. One being Bernoulli, which is caused by the top of the wings air having to go faster than the bottom of the wings air. And then we also discussed Newton's third law, which is basically every action has an equal and opposite reaction. Air pushes on the bottom of a wing and pushes it up. Right? We discussed the faster you go, the more lift that there will be, and we also discussed about stall. We talked about parasitic and induced drag. Parasitic drag literally just being caused by dragging a body through the air, and induced drag being drag that is caused by an increase in lift. So if you're just now getting in here, all I've done so far really is a recap and what to expect over the next week, since next Wednesday will be our last webinar. So you didn't really miss anything. I just did a quick recap on everything. And so life is good. What I ended up on last class was an exercise for you to test the differences in airspeed with the flaps up and flaps down on your King Air. We compared the airspeed, the lift, and the drag on both of these, and just basically to investigate the differences with, like I said, the flaps up or down. So just to see a little quiz here if y'all understood what I went over last class. When you deploy or lower your flaps, what does drag do? Does it increase or decrease? Okay, I see one good answer. Drag does slow you down, so that's the answer for the next one. Drag actually is going to increase. Alright, so lowering the flaps does cause an increase in drag. What about lift? Does lift increase or decrease when the flaps are deployed? It's counterintuitive. Lift and drag aren't mutually exclusive. I see one good answer. Lift is actually going to increase with the flaps down. A little bit counterintuitive, but if we talk about Bernoulli's method of drag, when the flaps are down, this has to travel a much farther distance. Has to travel a lot faster than the air on the bottom of the wing. And this differential of pressure makes this configuration have more lift than this one. So the question is, how do you reset your plane to its initial position? What I normally would do is just go into the quick flight setup and click on go to this airport. So we'll be discussing this more today. The question, I'm not a big fan of how it's worded, but if flaps only increase drag and not lift, it would be dangerous to land a plane. Why would this be? And I want you to think about how speed and lift are related. What could happen to our plane if we're coming in too slow and basically don't have enough lift? Any ideas? We talked about this phenomenon, which occurs when there's a rapid loss in lift. Your plane will start falling. What is that called? You would crash because you would be falling, but more specifically, it's stall. So stalling is just you're falling because you don't have any lift, which you can recover from as we discussed last class. But yeah, you got it right, Leo. It's stalling. Okay? So with that said, I'm going to go ahead and move on to the next lesson, which is about thrust. Alright. So thrust is this last force that we haven't yet discussed. It acts along the plane direction of flight in parallel to its longitudinal axis. And when the plane is accelerating, thrust is going to be a greater force than drag on the plane. I'm going to take just a second now and give you another thought exercise. When the plane is going at a constant speed, not ascending or descending, there will be two quantities that will be equal on here. So what I want you to think about is if you're not going faster, if you're staying at the same speed, which of these two quantities, or which two of these four quantities, would be equal? It's a weird thought, and I'll tell you in just a second. Alright, Abigail got it. Lift and gravity, or weight, would be one of them. Yeah, looks like Leo got it too. So you're not going to be having more lift than weight. You're not going to be going up, or less lift than weight, or going down. There's two more. And it's, at this point, a moot point since it's the only other options that are going to be equal to each other. Thrust and drag. Exactly. So when we do lift off and go into flight, thrust has to overtake drag. But when we're flying and life is good, staying at a constant speed, thrust and drag will be equal. So cool little aside I just wanted you to consider. So when we do land our airplane, which we'll be trying in just a second here, I do want to say that thrust is what determines the altitude of your airplane. So when I add power, when I throttle up my aircraft, more lift is being generated on my wings. Right? When more lift is generated, that's what makes it go up. Similarly, if I throttle down, less lift is being generated, and so I will descend. And that's a principle that we're going to be using extensively when we do land. So I know, like I said, I know some of you had probably landed before, but there is a specific way I would like for you to land. I don't know, I think it's kind of cool, not just some crazy, wild landing, sort of like some of your initial takeoffs. So alright, landing. So before I continue on, if you can go into X-Plane, if you got it working and life is good, I do want you to go into your quick flight setup. You play with a Real Flight RC aircraft simulator. Well, if you can get something similar going on with your game, that would be awesome. If you can find, a simple airplane and try to land it, that would definitely work. But I want you to choose the Cessna 172 again, Airport Lowy, and the final approach of 3 nautical miles. So a lot of stuff that we're going to have to remember when we do land. I'm going to give you just a second to get everything set up. I would like for you to raise your hand once you've gotten your simulation set up. So Cessna 172, 3 nautical miles, and Lowy. And if you do exit the quick flight setup, I do want you to pause. You don't have to exit it quite yet. Alright. I'm going to put the hands down. There's a couple of things that we do need to take into consideration before we land. Okay? We want to set our throttle so that our RPM of our engine, which is right here, is somewhere between 16 and 18. So I see a question real quick. You haven't even taken off yet? I mean, have you tried a good takeoff before? Do you just crash or something? Oh. You're supposed to be starting at 3 nautical miles. You're supposed to be starting by clicking right here next to runway 08. And then pausing so we're coming towards the airstrip here. Yeah, I thought she said you'd never taken off, and I'm like, you've been to every class. How have you not taken off yet? Okay. So we're trying to set our throttle so that it's between 16 and 18. So let's think. Do we want to push our throttle in or pull it out to do that? We're going to reduce how much power our engine is putting out. Do we want to increase throttle or decrease throttle? Anyone? I can almost hear the crickets chirping. Yeah, we're going to want to pull off on our throttle. So this is actually a little bit easier to do in real time, so I'm going to hold off on doing that until I finish talking about all my spiel here. We're going to want to keep our airspeed indicator somewhere between 75 and 85 for the entire duration of our landing. Okay? There's one thing I'm missing. What is that? Throttle. Oh, right. We want to keep our wings level during the duration of our ascent. Or descent, rather. So what I mean by level is you're not going to be doing too much with your mouse so that you move your nose up or down. We're trying to land solely with throttle. So there's a little bit of leeway here. You can move your mouse a little bit if you're trying to, adjust your position. But you shouldn't be doing a dramatic climb or a dramatic descent, okay? So, what should my RPM be? What am I looking for here? When I say 3 nm, When you go to the Lowy Airport right here, underneath final approach, you'll see 3 nm and 10 nm. Next to RWY08, you want to click on 3 nm so that we're close to the airstrip so we can land. What about Eminem? Well, if I had some, I would probably be eating them right now. That's all I have to say about that. So anyways, what should my RPM be? Want to make sure y'all got this ready. You want to keep it steady at this RPM. Should it be 0? Should I cut my engine off completely? Should I keep it where it is? Should I increase it? Should I decrease it? Looking for a number here. Anyone, please. I won't proceed unless I get answers for these questions. Alright, thank you. You should decrease. It should be between 16 and 18. Thank you. That's what we're looking for. So, you're just looking for this indicator to be right here. What should my airspeed be? What should this guy be? $75 to 85 or 70 to 80. That's a good general number. 70 might even be too slow, but 75, 85 is probably a good number. If you're coming in at 100, that's a little bit too fast. And if my crosshairs are right here, where should my mouse be? Should I be doing climbs and stuff? No. You got it. So there's one more thing that I haven't yet talked about. And that is going to be called our Precision Approach Path Indicator. Or, as I like to call, Poppy, because I think it's a funny name. You can't really see it from where you start too well. It's these white and red solid lines on either side of the runway here. What these do is help you land, and they're actually very helpful. So if you get a little bit closer to it, you can't really see it right now, but there's actually 4 dots on either side. And these dots will actually change colors depending on if you're coming in at a good altitude or not. If all 4 or 3 of the 4 of these are white, you're coming in too high. If all or most of these are red, you're coming in too low. If these lights are half red and half white, you're going at a good height and everything. Now, because we're controlling our descent almost entirely by the throttle, if we're coming in too high, do we want to do we want to get more throttle or less throttle to get on the runway? And I'll address your question in just a second, Lauren. If I'm coming in too high, do I want to give my plane more power by pushing in the throttle or less by pulling off it? Yes. If you see this, pull off on the throttle. Now the question is, what if you do if the plane flips upside down? You are going to want to make sure your plane is right side up, because otherwise you're not going to have a good time. You're never going to land your plane upside down. If you do, you need to abort that landing immediately. So if it flips upside down, I would probably just restart or see what you can do to right yourself and fix that issue. That's a good question. I actually got that question last class too. Only like acrobatic airplanes could even think about doing that, or VTOL, which we're not going to do much about. So if I'm coming in too low, do I want to give it more throttle or less throttle? Yes, more throttle. So if it's white, pull off. If it's red, push on. What if it's half white, half red? Exactly. You stay the same. You don't do anything. You just concentrate on keeping this poppy perfect and keeping your plane coming in perfectly for the landing. Now you said you flipped your plane upside down and you landed up right side up. Okay, that's weird. Not what I would have expected to happen. But you might notice that this is not the most realistically accurate sort of game here. So it's a flower? What do you mean? Oh, poppy. I guess it's just the way it's spelled that makes me laugh. Poppy. So anyways, if you do all that, once you do reach the runway, you want to throttle down and hit B on your keyboard to brake. Alright. I'm gonna warn you, your first landing is very rarely gonna be nice. It's gonna take you a little bit of practice to get decent at landing. So what I'm gonna do real quick is show you a landing. It's not gonna be a good landing without crashing, but it's gonna be a landing. I'm not very good at this myself. It's kind of difficult. Y'all pick up on stuff a lot faster than I do now. So, if you're not comfortable with it, without crashing, of course, I will do my best to tell you exactly what I'm doing. Now, I tend to go a little bit fast on the speed, but throttle does help here. So before I even get started, I'm going to pull out on the throttle just a little bit. Make sure I've got the white box around my crosshairs, and I'm going to go ahead and get started. Try to keep my plane level. Right now I'm just focusing on making sure my RPMs are good. I'm going a little bit low actually, so I'm going to throttle up just a bit. I'm going to try to keep my plane going relatively straight. So I'm still watching the poppy, trying to keep my plane level. I'm not very good at it, but forgive me. Making adjustments constantly in my flight. This is actually a really good landing. Wow, I've never done this well before. Normally I'm like everywhere. Making sure my airspeed indicator is about 80. So I'm coming in a little bit too high. So I'm going to put my nose down just a little bit, just a wee bit. So I can get that poppy being half red, half white. I'm still coming in too high. I'm coming in way too high now. Pull off on that throttle some more. My airspeed's getting a little bit high there. So right now my throttle is almost completely off. I'm still coming in too high though. Up here we go. So right now I'm just focusing on getting my Airplane roughly centered on the landing strip. Oh, coming in too low. Gonna throttle up just a little bit. I'm still coming in too low. There we go. So once I hit, I'm going to throttle down and brake and keep myself going roughly straight down the runway. So you see it's a little bit delicate of an operation. But it's doable. So what I'm wanting you to do is get some practice doing a couple of landings. I don't expect you to do completely great the first time. If you do feel comfortable with your landings though, you can also try doing it with your flaps down. The flap button is 1, 2, 3, 4 instruments to the right of your throttle. If you do choose to do a flaps down landing, if you feel comfortable enough to do it, you'll need to go just a little bit less throttle, which will slow you down a little bit. So I got a question. Helicopters are more fun to fly because you can do loops and stuff. Easier than planes, but planes are easier to land. I'll agree with that, but helicopters are also a little bit more dangerous. In real life, especially. Can you still hear me? All right, nicely done, Lauren. But yeah, landing's not very easy. I'm gonna be real here. I only did okay at it because I've done it a million times before. Even then, I still crash maybe a quarter of the time. So give it a couple good landings. I'll give you 7 or so more minutes to do it. I'll be here for any questions. If you feel really comfortable too, you can try landing with other planes. I had somebody land a 777 last class, or attempt to. I don't know if he actually succeeded. And also, if anyone wants to see my landing again, I will do it one more time just so you can get another explanation of it. So the question is, how do you get a helicopter? You can find it in the quick flight setup, but those are a lot different to land because they land vertically or very short. So what was that, Leo? Or an aircraft? But be noted, if you do want to try a different plane landing, you'll have to choose a runway that's not Lowy. Lowy is a little plane runway. Well, yeah, I guess you can go into aircraft and then open aircraft and change it. Either or. So yeah, go ahead, do a couple landings, try it with the flaps down. As soon as or I guess, never mind. I'm here for questions. think it's pretty cool, though, that you don't even have to worry about adjusting your nose on your aircraft to do a solid landing. So I see a question. The trees are so out of scale. Yep, luckily they make no difference in terms of crashing into them, so. A lot of the things are out of scale in this, though. Which really the important part is landing or crashing. And some of you might notice if you overshoot the runway that there is a body of water on the other side. If you do try to land on it, I think you'll just bounce off it if I'm hearing my last class's feedback correctly. Instead of skipping rocks, you're skipping airplanes. I'll give you about 3 more minutes if you don't feel comfortable landing yet. And at the end of that 3 minutes, I'll give you another minute or so. But after that, I am going to move on to flight control and stability. Whenever you try to land, your plane just flips over. When? Is it when you're close to the runway? And yes, skipping rocks is not quite as stressful, because there are no lives on the line. When you just start, you flip over. If when you start, you immediately flip over, you need to just focus on keeping your plane level, keeping your mouse on the crosshairs. After a few seconds. Alright, before you worry about doing any of the throttle stuff or watching your speed, I just want you to try to fly level for a couple seconds, and then pause it, and then start adjusting your throttle and stuff. I'm wondering are your flaps up? Or are they down? If they're down, you're not going to have a good time. You want to put them down a little bit closer to the runway. They're up. Alright, well what I want you to do when you first start and you pause it, pull off from the throttle a little bit and just focus on flying straight. You landed, took off again 3 times, then landed. See, that's pretty impressive. I'm not very good at returning back to the same runway I ended up on. I tend to run into the mountains. Any questions on the procedure or anything that we learned about thrust today? Did some loops? Well, you're using the RC airplane, right? A little bit easier to do structurally taxing things on little planes. And cockpit view, though, okay, that's pretty cool. I'll give you that. So I'll give you one more minute. Even if you don't feel comfortable yet, you always have after class. The Cessna 892, I don't think I know which one that is. Is it similarly sized to the, or if it was big, would it be similarly sized to the 172? Okay. It might be the 192. Or 182 maybe. Anyways, even if you're not totally comfortable landing yet, we're not necessarily going to need to know how to land. I just think it would be helpful for you to understand the forces of flight to have done this exercise. So you could always still practice after class. So that said, we have gone through all of our forces now of flight. And it's time to learn about the control surfaces that are on almost every single aircraft ever. Alright, so the Wright brothers back in the day, they were some pretty good engineers, and they defined the rotation of an airplane around 3 axes. So what I mean by that is, if you were to push poles all the way through your airplanes, there would be one center point, and it's just like a coordinate system, so just like your XY graphs. It's just like this in 3 dimensions. If you were to push a pole through the top and through the bottom, and then if you were to spin it, that is called yaw. I'll go more into these in a second too. If you were to push a pole all the way through it long ways, that's called roll. And if you were to push a pole all the way through the wings, that's called pitch. So let's talk a little bit more about that there. If you were to push a pole through your wings, we call it pitch. What that does is it moves your nose up or down. If your nose moves up, does your tail move down or does it move up? I just want you to think about it as if you are quickly rotating like a pole through the wings. I see a good answer here. Down. If your nose moves up, your tail's going to move down. And I'll go over that more in a little bit. There's something very specific about pitch that is different from roll and yaw. And it's a little bit weird, but we'll find that about that in a second. So yaw, which is if you're, wait, hang on, I see a question first. Nose goes up, tail goes down. Nose goes down, tail goes up. Question is, why is it called yaw? That's what the Wright brothers called it. I don't know. But if you were to stick a pole through the top and bottom of your airplane and spin that, that's called yaw. And exactly, what I didn't mention with pitch, and I'm sorry, I'll go back there real quick. Pitch is controlled by the horizontal tail, or horizontail, as one of my other classes mentioned. There is a control surface called an elevator. So what it does, if you push your elevator downwards, more air is going to catch sort of underneath it, and it's going to move your tail up, which moves your nose down. If you flip your elevators all the way up, it's going to push your nose up. Alright, so it's just sort of a reverse situation here. move them up, nose moves up. I guess it's not reverse. But anyways, I'll explain more about how that works a little bit later. Yaw is controlled by the vertical tail. There's a control surface called the rudder, and it can flip out to the right or to the left. So if I'm considering this right, this side of the airplane right, if I wanted to turn right, I would flip my rudder out right. Air would catch, it would push the tail towards the left and go right. The nose would go right, rather. Alright. And finally, we talk about roll, where the pole is going all the way through the airplane. And yeah, Leo, you got it right. It's because the rudder is getting in the way of the air. It's pushing all this extra air is accumulating, sort of. That's not exactly how it works, but there's simplification here. All the air is accumulating in the rudder, pushes it. It's just like a boat in the water. Air is a fluid, sort of. Just like water. Aerodynamics and hydrodynamics and fluid dynamics in general is one thing. Aerodynamics is a little bit weird because it's non-compressible for the most part, but y'all don't need to know about that yet. That's a college thing. So finally, pull all the way through, we get roll. The airplane will move one of its wings up and the other down. These, or the control surfaces that control this, are closer to the wing tips, and they're called the ailerons. Now these work a little bit differently than the elevator. One aileron will move up to decrease lift, but increase drag. The other will move down to increase both lift and drag. If I were to increase lift on the left side by moving my aileron down, is my wing going to move up or down? It's going to move up, you're right. But to make it a little bit easier to roll, you would be turning right, but you'd be rolling right, really. To counteract that extra drag, we do add a little bit of drag to the other side and decrease our lift. What's the term for a nosedive? That's what you did? I think the proper term is nosedive. But yeah, so if one goes down, the other goes up, and it rolls upward from the side that's down. So we've talked about the control surfaces now. Rudder, elevator, ailerons, and we did discuss flaps, which are on the inside of the wing, mostly for landing purposes. So those are the controls, and now we can talk about stability. The boring definition of stability is the property of an airplane to return to its original position when disturbed by an outside force. So what this is saying is if you're flying through the air and you hit a patch of turbulence, what you want your plane to do is not, say, keep bouncing up or putting its nose all the way up. You want it to return back to how it was before the turbulence. Every single plane that you will ever fly in your life, unless you become a really, really good pilot, is going to be incredibly stable. If you go to an air show, your pilots might have planes that aren't very stable. Obviously, it's a lot more difficult to fly an unstable plane because the pilot has to keep making constant corrections to all flight controls to get it to keep flying normally, or however they want it to fly. So it's very difficult on a pilot to fly unstable planes, and so therefore most planes will be stable, whether that be inherently or by the use of electronic stuff. half the plane goes into the ground, they tell you to start over. Unbelievable. Yeah, I can't believe it, right? So anyways, there's two different kinds of stability. The first being roll and yaw stability. And the way that aerospace engineers make stability happen, it's built into the plane basically. It's called dihedral. What dihedral is? You successfully did a barrel roll. Nice. That's interesting you can do that in a Cessna because structurally those things cannot handle the G-forces and have their wings rip off. But anyways, dihedral basically means that your wing tip is higher up than the place where it connects to the plane's fuselage. Alright. So there are a couple different kinds of it. Straight dihedral, which is just one solid angle. Tip dihedral, which is only your plane tips are higher than the fuselage. And polyhedral, which is two different angles. Now how dihedral works is it's inherently stable in that if your left side goes down and your right side goes up, say by turbulence, your plane is inherently going to want its left side to go up and the right side to go back down. It wants to stay in this upright configuration here. It's not trying to keep barrel rolling or anything. So basically that is that's how roll stability works. Now if you remember what I mentioned, overall when the ailerons are in use, so when you're trying to roll intentionally, you are going to slightly turn your nose a little bit. I thought it was in this PowerPoint, I guess it's not. Your nose is just inherently going to turn. There's nothing you can do about it. Well, that's not true. There is something you can do about it. When your nose turns ever, left or right, it's called adverse yaw. How do you counteract yaw, though? Anyone remember? Yaw being when your nose goes side to side. How do you make that happen? If you want your nose to go side to side, which control surface do you use? An elevator, a rudder, or an aileron? Anyone remember? The rudder. Yeah. Aerospace engineers also have to consider that because adverse yaw does happen, the rudder also sort of moves with the ailerons when they're in use to counteract any nose movements. The pilot can also do this manually. So if anyone's familiar with the phrase crosswind, it's when the wind is going along your wings and not along the plane's body. So if you're going to land, you'll have to throw out your rudder to counteract the yaw the wind is causing. I highly suggest, if you're interested in seeing some crazy plane landings, that you go on YouTube and search not adverse yaw, well I guess you could, but crosswind landings. There are planes that will literally land, or almost entirely land, sideways. At the very last second, pilot will kick the rudder up and straighten it out so it can land. It's some really crazy stuff. I highly recommend you take a look at it. In fact, I might put a link to it on YouTube or on Edmodo, because you won't believe it. These pilots blow my mind. A lot of time at a flight simulator. So check Edmodo later. I'm actually going to go watch a bunch of videos on that after I end class today. But Google adverse yaw landing or crosswind landing. So like I said, dihedral provides stability. And the other kind of stability since roll and yaw are very similar, is pitch stability. So again, the pitch of the aircraft is completely provided by the elevators on the tail. And before I go into specifically crazy moment stuff, has anyone ever tried to shoot an arrow or to throw a pencil straight, just like you would fire an arrow, or throw a javelin, or anything like that? Anyone ever tried it? Shooting an arrow without feathers? What happens when you do that? Exactly, it's hard to do it straight. In fact, it's pretty impossible to do it straight unless you're in Magic Land or something. But that's because these feathers here give it stability. The wind sort of moves around these feathers, makes it so if there is some turbulence, it'll correct itself. And that's exactly what the tail is for. Both the vertical tail to move it yaw-wise and the elevator to move it, pitch-wise. We need the tail on an aircraft. If you go into Plane Maker and take a tail off, you can see how terribly it goes. It's very unstable without that. So, finally, my last thing I'm going to talk about is an analogy between airplanes, teeter-totters, and torque. So torque is just like a rotation. And I'm actually going to skip forward a few slides because I like this slide the best. We're going to compare the movement of an airplane along sort of its wings, so along the pitch, the point of pitch, to a seesaw. So we call the very center point of the airplane the center of gravity. So that's where these big, huge sticks that I'm talking about would intersect. And the center of gravity along the wings that controls pitch is just like a seesaw. So a seesaw has a center point called a fulcrum. That's the center of gravity. So that if a tiny force is applied on the very end or the very tail of your aircraft, the nose, a force is produced on the nose. So some of you already mentioned this earlier, but if I were to push the seesaw down on the left side, what happens to the right? It goes up. If I were to throw my elevator down, my nose is going to go up. Alright? So you need only a small force over a long distance to create a big force over a small distance. That's why the elevator is able to control almost the entire rest of the plane, even though it's all the way at the very end, compared to the nose. So, and that actually goes for all of the axes, but it's not as easy to tell. So that's why the aileron works as it does, and the rudder. Alright. And you can actually see this real quick in X-Plane if you go onto the runway and click on A to look at a back view. So real quick, I'm going to show you. I'm going to move my mouse up, which, remember, makes my nose go down. Look at the elevator, it goes down. That elevator's being the last thing. Same with up and left or right. You can see the ailerons moving in different directions, and the rudder going in a slightly different direction as well. So you can actually visualize this in real life. So it is 7, so does anybody have any questions on what we've done today? If you don't have any questions, you are free to go. But I hope that gives you a decent example on how exactly physics-wise this works.